Welcome students. In this video, I'll explain all the properties or features of object-oriented programming. That is encapsulation, data abstraction, inheritance, and polymorphism. Apart from that, I'll also discuss about modularization or modularity and message passing. Now let us first discuss encapsulation. As the notes given over here, encapsulation is the wrapping up of data and function into single unit, that is class. The data is not accessible to the outside world and only the function wrapped inside the class can access the data. Thus, this insulation of data from direct access from outside is called data hiding. So encapsulation leads to data hiding. You are hiding the data from outside world and keeping it safe inside the class where you have the function that access the data. Now what is data abstraction? Now abstraction means the act of representing the essential features without including the background details. Now from encapsulation we get that data is hidden and only the functions can access the data. Thus, for the outsider or the outside world, functions are the only essential element to know and call, whereas the data is kept out of the access from them. This is data abstraction. Now let us see this figure. If we consider real world and car as a class, so inside the car, we have certain mechanisms, like we have gear, we have engine, we have battery, we have brake, we have accelerator, and all these have their mechanisms also. And there are certain elements outside that, like starting the car, stopping the car, put the brake, or put the acceleration. Now the driver as an outsider can work on these four elements. That means he do not need to know the internal mechanism of how gear is working, how engine performed, how brake applied, or how accelerator works. What he need to do? He need to know how to start the car, how to stop the car, when needed, how to put brake, or when to speed up, how to accelerate it. So for the outsider, this becomes unessential part. The mechanism of these becomes unessential part. So those are kept hidden. And how these can be operated will be known to the driver or the outsider through functions. So if I take an object, say Maruti Alto. So if I take Maruti Alto as an object of class car, it has these all mechanisms and these elements or the functions. So whoever operating this car will need to know these things and work on that. So any object of car, maybe any car, Ambassador, BMW, all have the mechanism which is hidden and the functions which are given to the driver so that he can operate on the car. Now let us consider in a programming cell. Now see here, if I take, let me twist the video, let me take the class student. So if I have done a program on class student, I have done certain data members like name, roll number, marks, grade, remark. And I have added some functions like accept data that will take name, roll number, marks from the user. Compute grade, according to the mark it will compute the grade and put remark, and display data will display all the things. Now let us see these objects. Now I have two objects over here. One object whose data are this, like name is Amber, roll number 1, marks 98, grade being computed as A, and promotion or promoted is the remark. How this has been done? Through the function associated to the object 1, that is accept data. So accept data helps the object 1 to get these value. Compute data will compute the remaining portion and display data will display all. Now let us consider the second object. Name Rahul, roll number 37, marks 35, grade, okay, grade should be here E, and the remark is promoted. Sorry, not promoted. Wait, let me. Yes, so the second object has grade E and remark not promoted. Now how this has been done? Object 2 also have its own functions: accept data, compute grade, display. Through accept data it will accept these three values, compute data will compute remaining 2, and display will display all. So through object 1's function we cannot access object 2 data. Similarly, object 2's function will not change object 1 data. Object 1's data remains secure for outsider unless its function been called. Similarly, object 2's data remains secured until its function being called. This is the model of encapsulation as well as abstraction. This is encapsulation, data and functions together in one unit as class, and this is abstraction for the user. This part is accessible. When we access these, call these functions, we get this result which is hidden in the background. Yes, students. Now I'll discuss about inheritance and polymorphism. Let us go through the notes. What is inheritance? It is the process by which one class can acquire the properties of another class. The class that accesses the properties is called subclass or child class, and the class that gives the properties is called superclass or parent class. That means if I have an existing class and it has some data members and functions, using that class I can create another class where the new class can access whatever there in the existing class, plus it can have its own new data members and functions. So the existing class becomes the parent class or superclass, and the newly created class will become the subclass or child class. Now let us see the polymorphism. Polymorphism means the ability to make more than one form. In this process, one operation may exhibit different behavior in different instances, and the behavior depends upon the type of the data used. Polymorphism allows operation having different internal structure to share the same external interface. For example, if we consider in real world, we as a human being act differently in different places. For example, you as a student behave as a student in the class or the school, whereas when you move to your home, you are no longer a student there. Similarly, if you come to playground, you are neither behave the same as you behave in the home or in the class. So you behave there as a player. So you as a person behaving differently in classroom, in playground as well as in home. This is polymorphism. Now in programming, polymorphism exhibits through function overloading that we'll discuss afterwards when you learn the chapter functions or methods. Next comes modularity and message passing. What is modularity? It is the act of partitioning a program into multiple smaller modules that can be called from main programs whenever required. That means one program is divided in small different functions, and those functions will combine together and called when required. That is also known as modularization of a program. Now what is message passing? It is a form of communication between objects in object-oriented programming. Methods or functions are used to pass messages between the objects of the same class as well as different classes. Now let us explain it through some diagrams. First of all, inheritance. In programming term, if I say, let us take the example of Windows operating system. Now we all know there are different versions of Windows operating system at different time period. First is what First was Windows 1.0, 1.2.0. It comes in the year 1985 till 1992. Then Windows 3.0, 3.1. After that comes 95, 98. Windows gradually, then it comes Windows 8, 8.1, 10 and so on. That means what happened? When first Windows program has been done by the team, whatever the problem come there, new team take the same program code and those problems being removed and some new additions being added in the new versions. So the new team or the same team do not have to work more. Whatever existing logic, taken that and create a new. So for them, this becomes the parent programming. This becomes the new child programming. Again, from this one, some problems occurred or technology advanced. Then new program team created new operating system of Windows 95, taking the previous one and so on gradually. So this is inheritance. An existing class is taken as the base class and the new class is created with the help of the codes that is present in the existing parent class. And gradually one after another, this series goes on. This takes care in every version of every operating system or any form of software. Thus what happened? Inheritance helps the programmer to write less code than the previous one. In contrast to that, always the newer version gets more advanced technology, advanced coding. Now let us come to the polymorphism. Polymorphism, what I have discussed, same in external structure, but internal behavior is different. Let us take this one as a shape. Any shape can have an area. Now, if we consider circle as a shape, it has an area related to the circle. And again, I consider rectangle as a shape. It has area according to the rectangle. Similarly, we have triangle, square, anything. Whatever shape we consider, that particular shape has its own area. Now here what happened? Area of a circle will certainly not the same of area of a rectangle. So internally the area of these two shapes will be different, but externally both as a shape has a particular area. Now let us come to the last point, that is message passing. What is message passing? Objects communicate with each other. Now how objects communicate with each other? Objects has methods and data. Methods can only access the data. So both the object 1, object 2 has their own data and methods. So object 1's data can be accessed by object 1's method. Object 2's methods will access object 2's data. Now if they require to communicate, to send their data to each other, the method will take that responsibility. So some method of object 1 will take responsibility to pass the data of object 1 to object 2. Similarly, object 2 some method will take responsibility to pass the data to object 1. Hope you have understand the entire concept of the properties of object-oriented programming. Thank you.